Everyday meteorologists rely on Doppler radar to help us out to understand the atmosphere so we can relay the information back to you, the viewer. Now, the way this works is a Doppler radar will send out a radar beam into the atmosphere. This is going to be tilted up at a slight angle, a lot of times going to be in half-degree increments. That way it overshoots nearby trees and buildings and eventually make its way back up into the clouds so it can see what kind of precipitation and what kind of wind speeds we're seeing. Now, once that beam reaches the clouds and the precipitation, it'll bounce back off, just like a bat with sonar, coming back to the center of the radar. Now, the center of the radar will go ahead and interpret this information, and eventually it's going to be mapping out this data into charts and maps so we can understand it and relay it back to you. Prime example of this is going to be reflectivity. So not seeing too much in terms of precipitation across much of central Missouri, but off towards St. Louis, you're seeing a little bit of green. That's going to be those raindrops reflecting the data back towards the center of that Doppler radar, showing us that there's light drizzle possible. Now, as we start to look a little bit further into this data, you can also start to see the wind speeds depending on how that signal bounces back. So the red colors, those are going to indicate winds going away from the radar, while the green colors are going to be winds going back towards the radar. Now, the reason this gets so hard as we approach the winter season is going to be different temperature layers in the environment. So a lot of times the radar could be telling you one thing, but it just could be shooting over that warm layer, so we sometimes have some issues seeing what it is exactly. You have to adjust the tilt so we can start to see what layers are playing out. I'm ABC 17 Storm Track meteorologist Chance Scotch.